Good morning, everybody. How are you? Still not awake? Okay. So, well, it comes to the first talk of the day. I'm going to talk about WebAssembly. It's going to be like an introduction to this subject and small demos at the end of the talk. I would like to know how many of you know what is WebAssembly, or if you have worked with, or no idea what it is. Or, Oh, okay. Perfect. So, yeah. Also, the idea of this talk is to make it a little bit dynamic. So, if you have any questions, or if you want to stop some, to add some information, etc., you are free to do it. So okay, let's start. For those, let me see here. Okay. For those who don't know me, I'm Miguel. I'm a Mozilla Tech speaker. That's a group of speakers from Mozilla. We preach about open web technologies. Also, I'm a freelance web developer and a university professor. And I also like to promote open source technologies in many communities in Latin America and international. So, also, I come from Venezuela. It's not Minnesota. Many people confuse the word because it's really different, but the pronunciation is the same. So, actually, in the country of South America. And if you are fans of the Red Sox, I don't know if you know this pitcher, William Cueva. Well, he's from the same country as me, so in case you don't know him. Okay, so let's start about the real talk. Many developers love JavaScript. Some people hate it. It's up to you. But usually, I compare to love JavaScript to like loving your significant other, because usually when you partner, you love him or her. But you know that it has some downsides and some things that you don't like it, but you just ignore it. So it's like that. So you can be good with that. So it's the same with JavaScript. JavaScript has some problems. And usually if you love it, it also, you just skip those problems in order to have a pretty good life. So, and one of the things that it has is performance issues, because JavaScript I wouldn't say that it's really slow, but it has some performance problem because it was never designed to be like that. Usually, JavaScript, I don't know if you know the story, but JavaScript was created like in 2 days in a hackathon at Netscape. So it has some problem from design point of view. But I know that many browsers vendors has invested a really good job and time in order to improve the JavaScript performance. But I wouldn't say that we are reaching the limit, but usually it's harder each time. So there's no way to keep doing like that. I mean, to try always to improve the JavaScript virtual machine. So they have to be like a new way to execute programs faster for the web. And one of the things is that this is how currently browsers run JavaScript code. Usually are these 4 steps involved in order to execute JavaScript code. After you download the JavaScript code, you see that the first one is the parsing. Parsing is when you download all the JavaScript code, the browser starts to identify each word, or let's say like each token word. Like when you are hearing like a language. I don't know if many of you talk another language. When you hit a word, usually you try to identify if that word exists in the language, and you then check for the grammar, to check for the order. So that the same process is applied by the browsers to JavaScript. It checks that each word, each reservoir key is correct and is in the correct order. So it has like a meaning. After all this process and checks that all the code is OK, it applies a compile and optimize process. So it means that it compiles into the browser's virtual machine and tries to do some optimizations in order to run the code faster. This might sound like it takes more time than it should, but actually when you spend time compiling and optimizing the code, it will run faster than not doing it. And also there is like a second step optimization, second stage, because there are some optimizations that you can apply after you do the initial optimization. So that's it. And then you just execute the code, and sometimes after you execute the code, there is a garbage collection process that it checks for any unused memory and frees it from memory. Also, I forgot to tell you that if you sign up into this conference on sketch.com, You can download the slides in there. They are already published in there. OK, let's see an execution example. For example, this is like a small function in JavaScript that usually everybody who starts learning a language does these kind of things. And it's just an addition. If you see, it has just two operators, A and B, and it should return the sum of both values. And you may think, OK, this is pretty simple. It should be executing one single CPU instruction because all the CPUs has a sum and addition and a sum operation. But it doesn't. It's not so simple as it is because in JavaScript there are many steps involved. Just for this addition, these are the steps that it has to do. ECMA 262, it's the standard that defines JavaScript. And in one of the sections, it defines how an addition should occur. And if you see, the first step is that it checks for the first operand on the first parameter, what kind of what it is. For example, if it's an expression, then it goes to the same step, but to the expression itself. If it's not an expression, then it checks the value, then applies the same process for the other operand. In this case, B, for example, the right parameter. And for B, it checks also if it's an expression. If it's an expression, well, repeat the step for the new expression. Otherwise, it gets the value. And when it gets the value of both parameters, then it starts to transform into a primitive. A primitive is when in a JavaScript virtual machine, there are values that are called primitive. They are like the low representation of a value. So when I try to change it to a primitive, it could be a string, an integer, a float, whatever. So if both values are numbers, it makes the addition. But if one of them is a string, it just concatenates the values. So if you see, all these steps are required just to make a simple addition. Something like that should be a simple one CPU instruction. It now became something like 8 instructions just to execute that. And if we think that addition, we put it inside a loop, then we see like the code will be getting like more slower. And for example, something that should take one CPU, it should approximately takes like 8 instructions just to run it on JavaScript. So that's what is JavaScript is not designed for performance. And you may wonder why that happens. Usually because when we design programming languages, we have to make some sacrifice. And for example, we have to, because developers only understand programming languages, but computers understand binary or low-level code. So we have to make a balance between those two sides. If we want to make a faster and really performance language, we have to move into a low-level code. Most developers will have a lot of problems trying to code for that platform. But if we do the opposite, we create good languages that are really to understand and easy to maintain. We usually we will have problems to make it run faster or to move it to a low level. So that's the main problem about programming languages. So how we can solve this? There is a new technology called WebAssembly. Well, not so new because it has like 2 or 3 years. And because currently, if you want to execute something in the browser, you have to do it on JavaScript. There is no way to do it before WebAssembly. But now with WebAssembly, you can code in the language that you want, compile into this format, and you can run it into the browser. Also, you can. It's a binary format, so it means that it's like precompiled. It's not something that you write in this. You just write in your programming language, and it will get compiled into WebAssembly. And also something that you have to be careful is does not reply JavaScript. Many people think that WebAssembly is a new technology that is going to move JavaScript from the way, or it's going to be replaced. But actually, the logo is like a puzzle attached to the JavaScript logo, because what it does is going to be a technology that will go aside from JavaScript. They will go in the same platform. And WebAssembly is a binary format, so it means that it's a binary. It's no text code. Usually we do on JavaScript. Does not replace JavaScript, like I said. It's a new technology that you can use as an alternative. Also, it's an interface from JavaScript. What does it mean? It means that you can code from your programming language. It could be PHP, Rust, C++, and make JavaScript calls inside your code, or vice versa. You can, from JavaScript, you can call C++ or C functions and execute call code from different languages. If you have programming with .NET, it's the same thing. Usually with .NET, you can write, for example, a function in C Sharp, and then you can write another library in Visual Basic, and you can call one code from the other, and it doesn't matter what you write. You can call between languages. So it's the same thing. Also, it has web API integration. It means that you can call, for example, WebGL, Web Audio, all the technologies that you can have in a browser. It can be accessible from WebAssembly. It introduced new types. It includes, for example, float from 32 bits, integer from 16, 64, and 128 bits. Then currently JavaScript doesn't support it, but WebAssembly supports. And SMID. SMID are single instruction, multiple data. It means that you can execute instructions that handles multiple data. So it's like it's not real parallelism or multi-programming, but you can at least do multiple operations in one instruction. So, and WebAssembly supports it. It's easy to compile, verify, and extensible. When I say extensible, means that WebAssembly can have new versions of the specification, and it will be backwards compatible. So the JavaScript virtual machine can execute WebAssembly code no matter what version it is. And also supports memory blocks of 1 byte. The memory in WebAssembly is handled by a JavaScript array with blocks of 1 byte. Now, this is how browsers run WebAssembly. It involves less steps as JavaScript, so it will be a little bit faster. What it does is, since it's a binary format, it just reads the code and it will decode the instruction. If, for example, if the instruction is 0045, it will decode it, and okay, 45 is like supposedly like a multiplication. So it will execute that command. And it can compile and optimize it to, I mean, it's binary, but the interpreter or the JavaScript virtual machine can re-optimize that code on real time while it's being downloaded. And also then it's executed, so it will be faster than running JavaScript. And here an example of how it's a binary format. There is a great web tool that you can use so you can inspect how it's the binary format of any WebAssembly code. And usually we can see it like this. The yellow part that you see there are the first 8 bytes. The first 4 bytes just are ASCII values that I don't know if you can see there. Let me just check here. Okay, better. The first 4 bytes just are .sam. And that indicates to the browser that, okay, this part of code or this file is a WebAssembly code. Then the next 4 bytes indicates the version. If you can see here, it has 010000 because it's the first version of the specification. Also, it has information like where is the global variables, the function code, many instructions that are how will be the initial memory of the application, etc. And the cool thing is that while the browser is reading that, it can do the decoding and the optimizations on real time, so it will be faster than reading just text and adaptive. That's the binary format. There is also a text format that also includes WebAssembly for people who want to code at low level. And you don't have to learn this, but it's really usable so you can know what's going on in the binary format. For example, this is just a hello world. And you can see here there is the new WebAssembly types. For example, here it defines the first parameter, so it's defined, and the type is I32, so it's an integer of 32 bits. And import the instruction to print from system, and since it's going to use just a printf hello world. The text format is not for us to code. It's just so you know that you can have this format in order to. It's like an intermediate format, so you can migrate it into any platform. And remember that we don't use WebAssembly. I mean, we don't code in WebAssembly. We just generate code into this format. Also, I know there is I don't remember correctly the name, but there is a security company that is doing an encryption tool in WebAssembly. So the idea is that you can run some custom encryption inside your browser. And they are coding the encryption tool in this format because they don't trust the low-level compilers. So there are people that use this, but for any specific reason. In that case, because they don't trust in any compiler, so they prefer to do the tool on with low-level code. Many of you may think that it's just a trendy thing, and it's something, oh, no, this is WebAssembly, so it's like a trend, and it's going to be away, and it's something that in 2-3 years it will be forgotten. But no, it has great support. And actually, it's one of the few technologies that I have seen that all the browser vendors have come together in order to support it and start working on it. Mozilla is the first one to have like a draft of it. It was called SAMJS at the moment, but then Microsoft joined to the project, and they collaborate with their .NET experience. So many of the things that you see in WebAssembly comes from the .NET platform. Then, after like 1-2 years, Google decided to join in. They had their own format called NACLL. I don't know if you use it. It's native client, so they dropped it and started to support this. And Apple, after the pressure of many people, they decided to join it. And now currently WebAssembly is supported by since past November, is supported by all the main browsers, so you can start running this code. So you may wonder how it's created. I mean, how do you can create WebAssembly code? The idea is that each compiler adds supports to WebAssembly. It means that you just have to execute your compiler, your favorite compiler, or from your language compiler, and will create the WebAssembly file. Currently, the only 2 languages that support this are Rust and Go. With both languages, you can code your code in there and take it to the web by just adding these flags. In Rust, you just set the target as WASM 32 bits. Sorry, WASM 32. And in Go, you just add these 2 global variables before compiling. After you do that, it will generate the WebAssembly file. And that's the road that it's going to take in the next years. Each compiler should add support for the WebAssembly target. Otherwise, this is how it's doing currently. But let's say that it's like a legacy process. It's going to be discontinued, and new languages shouldn't use this technology. Should add the support on their own compiler. But currently, there is a tool chain that takes high-level code to WebAssembly. I don't know if you know, any of you know what is LLVM? Or, OK. LVM, sometimes when you compile code, for example, to native platforms, something like C++, C, etc., there are multiple targets. For example, it could be Linux 32 bits, 64, OS X, 64 bits or 32, Windows, etc. Or if you have, I don't know, like a game console like PlayStation, Xbox, your watch. So there are multiple platforms. So create like a compiler for each of one platforms will take a lot of time and a lot of combination. So it's better to have like an intermediate language called LVM, which is like a virtual machine. That it doesn't exist in the real life, but it's a virtual machine that you can compile code to it. So then it will be easy. You just need to create a LVM compiler for each platform. For example, let's say that you create a new machine, a new architecture. If you add support if you make a compiler from LVM to your machine, you can use any previous existing compilers, like C++ compiler, etc., because you can take it from LVM and then to your platform. So the tool that I will talk is emscripten. What it does is that it takes LVM code and uses 2 tools, emscripten and binarium. There are some custom tools. And that takes LVM code to WebAssembly. So it means that any language that can be compiled into LVM, you can take it to WebAssembly with this tool. For example, you can code in C or C++, take it to LVM, then you execute emscripten, and it will apply all its tool chain. And after that, you get the WebAssembly code. And it might sound like a complex process, but at the end, it's just a command. For you, it's just only execute the following command, and that's it. You just execute MCC, which is the emscripten compiler. In this case, this is for C. Just put the name of your C program, add the flag for WebAssembly, and that's it. It will create the WebAssembly for you. So it's not that hard as it sounds. But like I told you, this is like a legacy code. The idea is that each compiler adds its own support. So may I wonder, okay, what do I get with this? I mean, after you compile and do all the steps, what do you get? Usually you get 3 files, which is first the WebAssembly file, which is like the binary file that I just spoke about it. Also the JS code to import the WASM module. Currently, for JavaScript developers, the browser has added support for modules. It means that you can, from JavaScript code, you can import code from another file automatically. For other languages, for example, in PHP, just like a require or a include. It's the same principle, but this is something new for JavaScript. So with WebAssembly, you get the WebAssembly code and the code to import. In PHP terms, it's just like a include your WebAssembly file. That's it. And of course, the HTML page in order to test the model. Also, one good thing about WebAssembly is that it's not just the performance, it's that you can interact between languages. For example, you can have a C function, and you can call it from JavaScript, or vice versa. This is pretty helpful because usually what you want to do with WebAssembly is to take your legacy code or any other code written in other language to the web. So instead of rewriting many things in your custom language or in your other language like PHP, you can just reuse code in JavaScript and call them functions. Also because currently there is no DOM support for WebAssembly. So if you want to change the DOM or do any related to the DOM or to the HTML, you have to do it from JavaScript. So you will need to call JavaScript functions from your WebAssembly code. And here are the samples. In order to work with WebAssembly, you have to work like in your language, like if you were doing a library. For example, in C, you have to wrap all the code inside the extern, I would say like the extern block, and like if you were doing a library. And then for JavaScript, you can import it. There is in the modules, there is a call called CWrap. And with CWrap, you can just call, for example, your C function, and you pass the parameters. The parameters are you call the C function, which is in --square root. And then just check the second parameter is the type of the value that you want to get. In this case, since int is an int in C, you just specify in JavaScript that you will get a number. And then you can pass any parameters that your function requires. In this case, it requires just one number. So that's why you pass an array from one number. And then you can start executing. You see code from JavaScript. So that's the idea. That the idea is the code that requires a lot of CPU processing. Like you can do it with C++, and then from JavaScript, you just call it. And you just will enjoy of big performance. And you can do also the opposite. For example, if you like the JavaScript alerts, for example, you can just define it with this call, emscripten run script. And then from C, you just, with this function, m-sam, you can start writing JavaScript code. And the cool thing is that you can, this looks weird, coding JavaScript inside C, but it's doable. So you can call to any JavaScript code from C, or PHP, or TypeScript, any language that you like. Okay, what can I do with WebAssembly? You say, okay, this is all theoretical things, so what can I do with that? There are multiple things you can do. For example, this is a demo on Firefox. What you see there is the Unreal Engine 4 that was migrated into WebAssembly. And in the browser, you can execute 3D graphics, sounds. For example, if it's a video game, you can execute the AI with high performance. And the cool thing about WebAssembly is that, for example, all OpenGL calls will get translated into WebGL automatically. Or if you have any audio, I think they use SDL Unreal Tournament. And if you have any audio libraries, it will get translated to web audio. What I'm seeing is that any, let's say, like access to the hardware or many libraries will get translated to the web version of them automatically. So you can reuse a lot of existing code. Also, I would like to show you this demo. I think it's already open here. Okay, let's see the resolution. Okay, these are our real-time demo. It will take to my webcam. Let me activate it. Okay. This is not a bug. This is a bug on my camera that, I don't know, it takes like, I don't know why the white color gets changed to another. Okay, this is the demo. For example, this demo, what it does is imagine a snapshot, because it will add some filters to the video source. And if we do that in JavaScript, it takes a lot of, CPU instruction and performance. So let's compare. I think I can change to grayscale. Okay. And we can see here, this is the comparison between running this code in WebAssembly and JavaScript. For this demo, for example, if I move a lot, you see that it takes around 33% or 100% faster than JavaScript code. Because it's grayscale. Grayscale is just removing like small values from the image, and it doesn't need as much performance as any other filter. So we don't see many difference. But if we switch to another, for example, I think this one will be. It's hard to. Okay. For example, we see that this filter is a lot of heavier. But if we see the comparison, WebAssembly is like almost 2,000% faster than its JavaScript version. Because here is when we see the difference. Because it requires a lot of mathematical computation, and also requires a lot of SMID instruction. And in these kind of things is where we see a real difference between JavaScript code and WebAssembly. So the idea is that, for example, application like a snapshot can be taken to the web without any plugins or any external tools. Or imagine, for example, I don't know how it's here, but usually in some banks in Venezuela, they're required to install you like a browser add-on in order to encrypt the communication and do some security things. And the idea is that you can do it with WebAssembly, so you don't need to install anything. You just download the WebAssembly code and will get executed faster than in real time. Okay, this is a small demo. And actually, you can see that, for example, in this, it's 200%, 2,000%, so it's really, really faster than running on JavaScript. So that's a demo that I can show you. Also, this is a tool that we made I work as a professor in university, and it's a tool to teach people in how to learn C language. The cool thing is that they just brought into let me see if I think the screenshot is on low resolution. Well, it's on Spanish. But the idea is that you can write all the C code. You just go into a website, and you have like an IDE, an editor. And you just write C++ code based on the elections. And you can run it, and it will execute it in the web. And you can see the results down there. So people can learn new languages and see the real-time instructions using only the web. There is no backend code that it's being compiled or any interpreter. Everything is running in there. Another example I would like to show you is AutoCAD for the web. I don't know if you've read this tweet. I think it was on the Google I/O on the past. I think it was on May. On May, the AutoCAD announced that they're going to launch Autodesk announced that they're going to launch AutoCAD for the web. So they took 35 years old code base into WebAssembly. And they managed to compile it and take it to the web. And they show some small demos. I think they are not public yet. I think you have to pay for the service. But the idea is that they could take an old application or an application that has a lot of C++ code, and also 35 years old code means that some part of the code might be old and coding might have problems, are not updated to latest technology. And they just compile it and take it to the web. And they save a lot of time, and they don't need to maintain two codes. They just maintain one single code base, and they can take it to the web just like any other compiled target. I think that this is something that is really important because AutoCAD is like a really heavy and really powerful application, and in demonstrating the powers of WebAssembly. Also, I don't know, for PHP developers, I mean, I'm pretty sure everybody knows WordPress. And WordPress is changing the internal editor for version 5.0. It's Gutenberg. If many of you have used WordPress in the latest month, you can see the alert message that, hey, migrate to Gutenberg, migrate to Gutenberg. Well, Gutenberg has a parser because Gutenberg is a new way to create content for WordPress. You just drag and drop blocks of content. For example, okay, I want a title, you just drag it. I want a paragraph, I want a slider. So you can build a website just by dragging elements, HTML elements. And they created a parser. I think it's made in Rust. And they compile it into the WebAssembly, and they are using it for parsing the code faster. And here there are some official benchmarks about it. For example, if they do it on JavaScript, it takes 13 milliseconds. But once they do it on WebAssembly, it takes 0.1. So it's like a 96% faster than JavaScript code. And even in this test, it's 300 times faster. So we can see that WebAssembly increases the performance of your code really, really fast. And the cool thing is that you don't have to learn anything new. You just can reuse your previous code. You can use your previous code, or you can use your current knowledge to create new software and just compile it to WebAssembly. Or better, just like AutoCAD, just recycle the code that already exists. And it will save you time from that. Also, I think that Angular, the latest version of Angular, are compiling parts of the core into WebAssembly in order to make the framework faster. Also, React. React is compiling their DOM, the Shadow DOM 3 interpreter into WebAssembly. So the new version will get faster by just only changing to WebAssembly. There is no to rewrite anything with that. And also, since we are in a PHP conference, I would like to show you PHP in the browser. Someone compiled the Zen interpreter and migrated to WebAssembly. So technically, we can run PHP code in the browser without any external tools, nor plugins. Let me show you here. Well, this is an example. For example, it already has some preloaded code. And this is, I don't remember, what is this? If this is the Fibonacci, well, and you can run and you can execute any code like that. For example, echo. This is a test. We click on run and execute it. So technically, we can now even create, recycle our PHP code and take it to the web. I don't know if you have sometimes problem when you have like a custom validation code, and for example, you create your custom validation code in the backend with PHP, and then you want to add the same validation into a JavaScript in order to protect the user from doing that. And sometimes it's like a pain to have the same code into a JavaScript. So it's like, okay, I already created, then I have to migrate it to JavaScript. And now I have to maintain the same code into multiple languages. The idea is you can, for example, do it with WebAssembly. Just have just one validation code, take it to the web, and you just maintain one single code. And it will be faster to run than any other tool. Also, I think I closed the wrong window. OK. So technically, with this, we can go full stack with PHP. Technically, now, in theory, you can create a PHP in the front end and in the back end, just like Node.js, but full PHP. And we can say bye-bye to JavaScript. No? So just kidding. But technically, it's possible to. It's a new door to do it. And also, there are future. Currently, WebAssembly is like it's like an MVP. It's doable. You can use it, but it doesn't have all the features that it should have. And the features that are getting in development is multi-threading and atomics. Multi-threading because it's really hard to implement because currently not all browsers, there is no multi-threading support in JavaScript. WebAssembly runs in the same JavaScript virtual machine. It's not something additional, it's just the same virtual machine. So it doesn't, current JavaScript doesn't support multi-threading. So currently WebAssembly doesn't have, so it's getting being added. There are two proposals to do it. The first one, the first version, it will be using service worker. So it will implement all the threads, will get translated into service worker, and that's how the browser knows. If you want to know service worker, there is a the current. I think it's in the same room. The next talk will talk about it in this room. And also atomics. I don't know if you know what is atomics. Any of you? Can you tell us? Would you like to share what is atomic or? Yeah. Yeah, that's true. And atomics, I think that the people in charge to implement atomics are the same people who are solving the same problem in Rust. So that's the idea to add support. Currently, there is no exception handling. So if your code fails, you'll see the fail in the browser. There is no error handling. Also, there is this is the most requested feature, is garbage collection. The garbage collection is mostly for languages that need it. For example, C++, C# or Java, and even PHP needs garbage collection. When it's implemented in WebAssembly, we can now compile from PHP to WebAssembly without any interpreter. It will be just like a native code. Also, global mutable variables, mostly for an SMID, full SMID support. And these two usually fall multi-threading. It's related to the first topic. Also, any WebAssembly currently has this type. It's WebAssembly E64, which are 64-bit integers. But JavaScript doesn't have anything like that. JavaScript just added big int, which is like a new spec from JavaScript. And the idea is that WebAssembly add compatibility between those two types. And there are many more. It's just those that are getting like added. And if you don't want to wait, you can just start now. You can just use this WebAssembly Studio. I have it here open. Well, I want to show you two tools. This one and the other. Yeah, it's on the back. And the other is WebAssembly Studio. Oops, yeah, opening the new tab. Okay, I will show you a little bit. Because now with WebAssembly Studio, it's like an IDE. You can start coding and testing WebAssembly code in there. Currently, it has support for C, Rust, and I don't see here, and TypeScript. So if you like to work with TypeScript, you can do it. For example, I think it's already a C code. Okay, and we can create it. And it creates just like a full IDE. And you can see, for example, main C, it has all the code. It might seem like complex, but it's just only a printf. And they are implementing like their own printf instead of using the standard one. And we can click on here on build and run. I think, it's returning 0. I think there is a bug last night in the tool. Somebody updated it and it's not working. But it's showing here. I was looking at the console. And it prints hello world. It doesn't seem like much, but you can have, I want just to show you that you can start coding in this and testing. There is no compiler, so you don't need anything. And it includes the code. For example, this is the JavaScript code. It's just a code to make sys calls, system calls. And it's something custom. I will tell you in a little bit why it's that. And here is the WebAssembly in text format, how it takes to print a hello world. And the HTML. For the HTML, it's just including a JavaScript file that loads the WebAssembly, and that's it. You can start working with this and testing, the code should be simpler. I mean, you can theory just the main. Okay, what I want to tell you is why they are the code. The problem is that you can do include Studio and use a normal printf. But WebAssembly will also compile the libc library and will include into the WebAssembly. So it will be like an extra space inside the file. So in order to avoid that, so many people rewrite some functions in order to make the WebAssembly code smaller and faster to download it. And also there's another tool that you can use. This WebAssembly Explorer, where you can just write, for example, a small code here. I think now it's so small that you cannot see it. For example, just only an hello world. Okay, include the studio. And we can compile it. And you can see it generates the WebAssembly text, so you can start, if you want to, for example, I'm academic and usually like to understand what is going on behind the compiler. And even it can show you what Firefox are compiling into the machine code, even to assemblers. So you can start inspecting how the code is translated into multiple things. This tool is getting deprecated because it's going to be merged with WebAssembly Studio. So, but in the moment, you can use it to learn. It's really cool to see. And actually, we can see how a simple instruction in C gets translated into a multiple assembler code just to run a hello world. So you can start using. So that's the idea. After the talk, you can start using all these tools on the browser. You don't need to install anything else. Or if you have in your works or personal project, you have something, some web application that is running slow or have performance issues, you can start trying to migrate into WebAssembly. So I recommend you these following links. This of the official WebAssembly website has all the information that you need. I don't know if you have used WebDocs. It's the Mozilla Microsoft website to talk about a lot of web development information. And their WebAssembly section is really cool because it's really simplified. Also, there is an article I would like to show you. If you want to go into even more details, it's the catch. Well, it's down now. Well, I can update it if the link is wrong. When it explains everything, all the binary structure with details, and it's really simplified, so you can start reading. Also, Mozilla Hearts is, I wouldn't say like it's the official, but since this project is mainly led by Mozilla, in the Mozilla Hearts blog, they usually post about new technology, and they have even a really cool article about with cartoons. This one, she has made some really cool articles explaining about WebAssembly with cartoons. So you can all the complexity can be learned in few words. So, oops, I messed up the zoom. So, yeah. So that was like the small introduction into. Oops, I don't know what I did with the. Okay. So yeah, this was like a small introduction into WebAssembly. Hope you like it. You tried to use it, and if you have any question or any comments on additional information, you can share it here. So, questions? Yeah, you will need to compile it separately, and WebAssembly model for each languages. But in the JavaScript level, you can just make the calls to like the join between all of them. You will need to do that. No, you can, right. You can also call it from, because technically, that's a pretty good question. I don't have it here. But yeah, for WebAssembly, you can call a function that it's in another WebAssembly, file. So you can do that also. It's like in .NET. You can call, we work like a library. You can just import the functions and you start calling between each other. Any other questions, comments? Usually many people are worried about the security. But the security is just the same as any other JavaScript code. It's just like, imagine that it's a minified JavaScript code. You might know what it does, but it has the same privilege. So it cannot access to the computer memory. It will access through the browser sandbox. It will be encapsulated between the browser's limits. I mean, there is no any other special code. There are no C calls. Everything is run inside the Java virtual machine. So. And also, I would like to add that, like Ryan said, I was talking with Ryan, another speaker yesterday, and usually we are used to in the web, everything is open. So we can just inspect, or even JavaScript code is minified, but we can decompile it, and you have like a small JavaScript structure. But here, since it's binary, it will be like I don't know how to say, like maybe we'll close the web a little bit because many people will try to migrate the code to WebAssembly, because since it's binary, people won't understand or interpret what is the code running inside the browser. So, well, that's it. If you want to know anything more, just contact me. I will be around the rest of the conference, or you can write me anything, etc. And that's it.